If you used Linux for any period of time, you're probably familiar with LiveCDs, which are self-contained operating systems on a disk. They're usually just a matter of popping the disk in, rebooting, and a few moments later, you're at a fully functional desktop ready to go. However, if I were to ask you what the first Linux LiveCD was, what would you answer? If you said Yggdrasil plug-and-play Linux, then you either know your Linux history or you really like pain. Now, I never used Yggdrasil before, but it's a name that keeps coming up with an air of fondness whenever I talk about vintage Linux. A quick read through the manual had plenty of bold claims and some rather unique selling points which inspired me to take a closer look. To be honest, I was rather skeptical of these claims, especially since CD-ROM support in early versions of Linux is not what I call particularly good. As such, was this fondness a case of misplaced nostalgia, or did it have something that the history books had otherwise forgotten? As it turned out, much to my surprise, there was a lot more here to explore than I was expecting, although this was offset by the fact that getting Yggdrasil to boot caused me a not insignificant amount of heartburn. As usual, this is your host NCommander, and this time we're exploring one of the roots of the world tree itself. Or, well, as soon as I can get working media. Up until relatively recently, Yggdrasil was considered a lost media distribution in which it was known to exist, but there were no preserved copies of the CD-ROMs. iBiblio, which is one of the largest collections of ancient Linux and Unix, only had a set of tar files, one from 1994 and 4 from 1995, and all of them a bit strange. The 1994 Yggdrasil archive appears to contain an installed system, while the 1995 archives seem to be mislabeled and just contained random snapshots of various FTP archives. As such, I thought this story would begin with trying to reassemble a working image, and well, I did end up having to do that, but on a hunch, I did try a last-minute Google search. It seems within the last year or so, someone has actually archived quite a few versions of Yggdrasil Linux, and they have posted ISO images. I examined all of these to some extent, but for this video, we're mostly going to focus on versions from 1994, as they have some unique features that were dropped in later releases. Now, unfortunately, actually starting Yggdrasil isn't quite as simple as one might hope. This is primarily because there was no standard for a PC to boot from CD-ROM until 1995, and even then, it wasn't widely adopted until many years later. For instance, my 1997 ThinkPad 380D has a built-in CD-ROM drive, but if we look in BIOS, there's no corresponding startup option. From what I can glean from the manual, Yggdrasil Linux shipped with a boot disk that was used in tandem with the CD to start the system. Fortunately, an image of said boot disk appears to be included on the CD-ROM, so it should be easy enough to recreate. First, we need to install MS-DOS 6 followed by Windows 3.1 and then add a side of Oak CD-ROM for disk support. Afterwards, we can use raw write to create the boot disk. It's at this point though that we hit our first snag. Upon rebooting, we're greeted with an LI prompt and then a system hang. Obviously, this was going too well. For those not familiar with Linux boot failures, this is the way the first stage Linux loader, or Lilo, sends up the white flag when things have gone south. According to the documentation, this is what's known as a geometry mismatch, or in simpler terms, it's when Lilo can't find itself. This isn't a rare problem on hard drive installs, but it's extremely unusual to see it on a floppy boot disk. In fact, it's suggested that the disk image on the CD was corrupted in some way. That seemed unlikely, but when I went to take a closer look, I noticed that the disk image I was writing was 720 kilobytes in size, which meant that it was intended to be ran on a double density disk and not a high density 1.4 megabyte one. Mismatched floppy disk sizes could cause this type of failure, but I was rather skeptical since 720K disks were essentially obsolete in 1994, but for the sake of my sanity, I tried it. I'll take bets on if you think this worked or not. Honestly, I'm not sure I would have bet on this outcome. I actually thought that this was an emulation glitch with PCM, but I was able to produce the same failure mode on everything I tried. I even went as far as to get my ThinkPad out and try it with real media. As we can see here, writing it with a 1.4 megabyte disk causes a system hang, but using a 720K disk, it in fact starts successfully. After getting tripped up by this, I ended up checking the manual, and well, it does note that Yggdrasil does expect one to use a 720K disk. I guess that's on me for not reading the fine print, but I still consider it a rather strange decision. Now, at this point, I was expecting problems, but as I found out, if you just press enter at the Lilo prompt, Yggdrasil will in fact see the IDE CD-ROM emulated by PCM and then boot up without issue. Let me make this clear. This shouldn't work. To make a very long story short, early Linux had very little support for CD interfaces. In practice, until approximately 1995, the only CD-ROM drives supported were either SCSI-based or one of a small number of Sound Blaster CD-compatible drives. To put that in context, the fall 1994 Yggdrasil release reports that it's running on Linux kernel 1.147, which was released in August of 1994. Meanwhile, the mainline IDE CD-ROM driver would first appear in kernel 1.176, which was released on January 2nd, 1995, or 4 to 5 months later. It was becoming pretty clear that Yggdrasil made extensive changes not only to the Linux kernel, but the system as a whole. We're going to pop the hood to take a closer look a bit later, but let's explore the system as it is before that. The login screen gives us 4 choices: to run a demo, install the system, log in as guest, or log in as root. I was also rather amused that there's a 900 number right there if you need help. I'm pretty sure I can divine a business plan from this screen alone. Still, so far, things have been working fairly well, so let's run the demo and change that. This immediately throws us to a setup wizard for configuring X. Now, if you've seen my previous Linux ventures, you'll know that trying to get X11 working on vintage Linux tends to scale fairly heavily on a combination of luck and faith. In defiance of this trend, Yggdrasil worked successfully on the first try. The setup wizard did everything right, and it was even able to auto-detect a working SVGA configuration. I didn't even have to open up the config file to fix anything. The fact that it did the right thing at all is, quite frankly, a bit mind-blowing. Of course, there was more to show here. After almost a minute of load time, the interactive demo began. This appears to be a showcase of basically everything included with Yggdrasil, including interactive media and more. 2 things immediately caught my attention. First, it appears that Yggdrasil wants to be running at a resolution of 1024 by 768, and secondly, it appears to be trying to play sound. The manual has an entire section noting that, by default, Yggdrasil is configured to support a Sound Blaster compatible sound card. I don't usually enable sound on my virtual machines, but in this case I'll make an exception. After a reboot, in which I also bumped up the resolution, we get to hear this.
Hi there!
This is then followed by MIDI music via the emulated OPL2 chip and even MPEG video playback. There was a part of me that was sorely tempted to see if I could get some old AdLib tracker working, but well, Sandy won that battle. As far as introductions go, this is probably the best one I've seen showcasing everything Linux can do in a single presentation. So far, boot issues aside, things have been rather solid, and this is the first ancient Linux distribution that I've used that an end user would have had a reasonable chance to get X working. I will note that if I had the original boot disk, I wouldn't have had any problems to begin with. Rather notably, it's a league better than the train wreck that was Debian 2.1 from 1999. That being said, this demo is rather notably lagging, and I'm emulating a 60 MHz Pentium with 16 MB of RAM and a 24-speed CD-ROM drive, which would have been a monster of a machine for that time period. In fact, there were warnings about the performance when we first started the demo. I suspect on an actual 486, performance would be, at best, glacier. In practice, while a LiveCD is a great novelty and selling hook, it's not really practical with the technology of this time period. It really wouldn't be until the turn of the century where systems would actually have enough memory and fast enough disk access that such a system would be usable in actuality. However, as an advertisement for Linux, it's pretty damn hard to beat this. I'll be honest, when I started on this topic, I expected the love for Yggdrasil would mostly be a misplaced sense of nostalgia, but it appears that it's actually justified to an extent. For the most part, Yggdrasil seems fairly well polished, but I was a bit more curious to see how they pulled this off. Modern LiveCDs normally use a compressed file system such as SquashFS or Cloop and decompress on the fly, but that wouldn't have been an option in 1994. Eagle-eyed viewers might have noticed that while I was browsing the CD under DOS, certain folders looked like the root file system of a Linux box. That is in fact how Yggdrasil works, with a twist. Normal CD-ROMs use what is known as an ISO 9660 file system, and normally they don't have the ability to store the necessary metadata required for a Linux root partition. However, there's a set of extensions to ISO 9660 known as Rock Ridge, which adds support for permissions, device nodes, links, and long file names with the express purpose of increasing compatibility with Unix. These Rock Ridge extensions allow one to create a CD image which can work as a root file system under Linux. This is how Yggdrasil essentially works. The Yggdrasil CD is simply mounted as the root partition. For temporary storage, a RAM disk is initialized and then symlinked into place. All in all, it's a fairly clean solution. However, that begs the next question: how much did Yggdrasil change in making this system? We already saw that they added IDE CD-ROM support, but as I would find out, they did a lot more. The manual has an incomplete list of changes made to the base kernel, which primarily consists of driver additions. However, two items caught my eye. The first is what the manual calls the inherited file system. This appears to be an early attempt to add persistent storage to a LiveCD or other read-only device. By using the smount command, I can merge a folder on the CD with one on some sort of writable storage, which acts as an overlay. This is conceptually very similar to how OverlayFS does persistent storage on modern LiveCDs, and it might have been something that Yggdrasil was experimenting with. Assuming one could live with the performance trade-offs, IFS had the potential to help create very portable installations via external storage. If Yggdrasil had not died, they would have been in a very good place to combine their LiveCD with the soon-to-become popular iOmega zip disk. That being said, I'm not certain how complete IFS is, and it doesn't appear it was ever merged into the kernel. Still, it's remarkably forward-thinking since it would be many years before this type of functionality would become commonplace. That alone was a noteworthy find, but Yggdrasil made one other major change that absolutely blew my mind. I'll read it out loud since the implications may not be immediately obvious. Yggdrasil includes new drivers which use callbacks to the 16-bit real mode BIOS and MSCDEX drivers to access otherwise unsupported CD-ROM drives and hard drives, and to allow the use of other BIOS service requests. Now, that might mean nothing to most people, but what it's saying is that Yggdrasil patched the kernel to be able to use MS-DOS disk drivers and BIOS services as a failback. That means, theoretically, Yggdrasil would work on any system that could run DOS and had a CD-ROM drive. We can even see a message about this if we attempt to start Yggdrasil and it can't find its root CD. If this worked as advertised, it would have solved many of the compatibility issues in early Linux. This type of DOS and BIOS fallback was actually common on most other operating systems. For example, Novell NetWare can use DOS MSCDEX drivers to load installation media. Conversely, OS/2 can use the BIOS as a fallback to access a hard drive. In comparison, Linux is unusual in that it has absolutely no fallback in case of a missing driver. Unfortunately, it seems that this feature is, at best, half-baked. In an effort to learn more, I attempted to test these drivers with a variety of both emulated and real hardware setups. While I was sometimes able to get the BIOS hard drive fallback to partially work, I had no success with loading MS-DOS CD-ROM drivers under Linux. It's possible that this feature is dependent on hardware-specific quirks that none of my machines have, as the code performs what can best be described as deep magic. In more technical terms, it's manipulating what's known as the x86 global descriptor table to keep DOS loaded in such a way that it's usable even after the Linux kernel starts up. It's possible this feature is dependent on specific versions of HiMem or specific versions of DOS, but I haven't had much luck. Making this matter all the more frustrating is the fact that I haven't been able to find any real information on these drivers, although based on the copyright messages, it does appear that they were developed by Yggdrasil Computing Incorporated directly. Unfortunately, a lot of the early Linux development discussions were lost in a server crash in 1995. As such, it's impossible to know if these drivers were ever submitted for potential inclusion within the mainline Linux kernel. It should be noted, though, that the last Yggdrasil CD I have, which is also from 1995, does not appear to include MSCDEX or BIOS hard drive support out of the box anymore, suggesting that this feature was relatively short-lived. That covers the vast majority of non-driver kernel-related changes, but Yggdrasil does appear to have gone beyond that. For instance, they actually added native compression pass-through via LD library path. That's something of a magic trick since Linux at the time still used A-out shared libraries, which can best be described as somewhere between quirky and flat-out painful. It does come in use if you want to browse the compressed source on the system CD, although I found it was a bit glitchy. I could probably spend a few days comprehensively documenting all these changes and more, but I think the point is clear. This is a heavily tweaked and modified Linux distribution. And now it was time to cover the last major hurdle, involving installation. To be honest, I expected handling system installation to be a relative non-event. Oh, how I wish that to be the case. Continuing the theme of authentic experience, I used FIPS to shrink the DOS partition and then rebooted back into Yggdrasil. Logging in as the install user automatically kickstarts the process. The installer is just a set of text prompts, but one nice touch is the use of cfdisk, which at least provides a proper user interface to do disk partitioning. The only major gotcha that I spotted was that the installer defaults to formatting dev HDA1, which, if you're dual booting, means that you'd accidentally format your existing DOS and Windows installation. Still, on the whole, it was a much more straightforward experience than what I had encountered with SLS or Slackware of the time. In fact, I thought we were home free right up until the installer hung while copying files. I retried the installation from scratch and once again hung, albeit a bit further. I spent a fair bit of time debugging this, and as far as I can tell, what's happening is that the Linux kernel is going into a deadlock. The installation process uses the tar command to mass copy files from the Yggdrasil CD to the hard drive. What I think is happening is that there's a race condition between the alpha quality IDE CD-ROM driver locking up the bus when used in tandem with the IDE hard drive driver, which then causes the kernel to hang. These early versions of Linux didn't have an integrated debugger, and honestly, I'm really trying to avoid tinkering with the kernel if I can avoid doing so, as I have already fallen down that rabbit hole more times than I can count. However, given the sheer number of modifications that Yggdrasil has made, I couldn't just drop a newer version of Linux under the hood. However, I did have a slightly newer version of Yggdrasil Linux on hand. The damaged Yggdrasil archive from iBiblio has a date code of December 1994 instead of fall 1994, and a brief examination showed that the kernel, and specifically the CD-ROM drivers, had been updated. Furthermore, while I could have just switched to a SCSI-based configuration, I did want to see if I could get this to work in some form. Given my explorations thus far, I was convinced that I could turn this loose collection of files back into a working CD-ROM image. In truth, it wasn't that hard once I could define the necessary options and permissions required to reconstruct a valid Rock Ridge file system. Afterwards, I could write a new boot disk and capture footage of this otherwise lost version of Yggdrasil. From what I saw, there are no major changes in the demo or included applications, but really what matters here is, will it install without hanging? The answer is yes, it will. Chalk went up to Team Reconstruction and Recovery. That being said, I did end up switching to a bus logic SCSI configuration not long after. The reason is that the IDE CD-ROM driver seems to be both abnormally slow, and I wanted to rule it out as a source of problems down the line. After letting all the files copy, we're prompted for the system hostname and if we want to mount the system CD automatically. This is an important question, but we'll dive into it in a moment. After installing Lilo to the master boot record, we're ready to reboot. After the usual boot messages, we're eventually dumped to a slightly modified version of the usual login screen. One thing of note is that the splash screen as well as the manual on the disk still have the fall 1994 branding. From what I can tell, the December 1994 release appears to be mostly bug fixes, since aside from the updated kernel, very little seems to have changed. More curiously though, is that if you run df, it will reveal that Yggdrasil only installs a little under 6 megabytes worth of software. Yet, all sorts of add-on software appears to be present, such as GCC. That's because, by default, Yggdrasil can dynamically load uninstalled software from the CD-ROM, and this also includes X itself. This is something of a mixed bag though. Because of the way this is implemented, the Yggdrasil CD must be present during system startup if you wish to take advantage of this capability and cannot be dynamically loaded or unloaded. This would have been a major selling point in the era of small hard drives, but it also means that one could not freely use their CD-ROM drive. Even if the core system files are installed either by using install component or the graphical package manager, it's still impossible to dynamically insert or eject the CD. If the user bin package is installed, then the user bin symlink is replaced with a real folder, but not all the files are automatically installed. For instance, Yak remains as a symlink since it's part of the DevTools package, and it's not always clear which packages will install what files. It should be noted that while it is technically possible to boot without the CD-ROM inserted, you can end up with a very inconsistent system as a result. On top of that, I also found that due to how the root file system is essentially symlinked into place, it can cause other unexpected breakages. We can easily see an example of this if I try to compile NetHack. First off, we get compilation failures due to broken header files. This is because the kernel headers, which are needed by GCC, are stored as gzipped files on the CD-ROM. While there is the LD library path pass-through I showed earlier, I found that if I wanted a sane compiler, I had to install the DevTools, GCC, and kern source packages. Afterwards, things started behaving right up until I ran the make install step, which failed to copy the game files. As we can see here, this is because user games is still a symlink to system CD. If I install the Yggdrasil games component, then this becomes a real folder and thus I can install NetHack. On the whole, I have no doubt that all these factors could conspire together to cause problems for a typical end user. Still, I'm hesitant to overly criticize Yggdrasil on this point, since it was literally pioneering many of the concepts that would be used by later Linux distributions. Still, I feel there's more to show, since Yggdrasil had, for better or worse, a fair bit of original flavor that I still want to document. Let's pop into X and take a look. Yggdrasil has a rather extensive set of homegrown software for managing most aspects of the system ran in Tcl and TK. Among other things, these interfaces provide full package management, network configuration, and general system administration. This is one of the earliest examples of integrated system management on Linux that I've seen. Rather impressively, there's a configuration UI for setting up dial-up networking, and the manual promotes Novalink, which is a Massachusetts-based ISP. It even goes as far as to offer a $40 credit to help get Yggdrasil users online. As I've stated in previous videos, getting dial-up networking to work under Linux was, at best, difficult, but if Novalink officially supported Linux, it would have greatly reduced the barrier to entry. Getting users online appears to have been an important pillar for Yggdrasil Incorporated, since the manual claims that they provide free outbound email to users pre-configured out of the box. How did they do this? Well, by allowing any Yggdrasil user to call their corporate offices and send email through their systems. Just to make this clear, this was done by placing an actual phone call to a California-based number, which in 1994 was something that could cost a fair bit of money and would happen whenever anything tried to send an internet-bound email. Did I also mention the part where this would all happen automatically? Now, maybe it's just me, but I can't help but think that this is not a good idea. But fortunately, after a careful review of the fall and December 1994 Yggdrasil releases, this feature, for want of a better word, doesn't actually exist. In fact, if we look at the UUCP configuration, a placeholder phone number is present in the dialers file. That being said, I did find that at one point, this feature existed and Yggdrasil Linux literally phoned home by default. On the summer 1994 release, I found a complete UUCP configuration file that would let the system automatically place outgoing phone calls as needed. I'm still baffled on how this is a thing that actually exists. I can only assume that the practical problems of having your customers' computers automatically place long-distance phone calls is why this feature was removed not long after. That also sums up my final takeaway on Yggdrasil plug-and-play Linux. Like many things we've seen, the concept of making email easily accessible was a good one, but the implementation was kinda half-baked. However, on the whole, I do actually consider Yggdrasil to be a high point of the early Linux years. It pushed the limit of what was possible with the technology of the time period, and even now, it set a high mark for usability that few other distributions wouldn't match until years later. The demo display is still one of the best sales pitches I've seen for early Linux and provides an epic wow factor. There's still plenty more I could talk about, such as the inclusion of a purchasable OSF motif add-on or its inclusion of the Andrew user interface system, but I think the point has been made. Yggdrasil was an extremely ambitious, if somewhat flawed, Linux distribution that could have had a much larger impact had the technology just been a little more capable. Still, that brings us to the final question. Just what happened to Yggdrasil Linux? From what I can tell, the final Yggdrasil release was in 1995. After that, Yggdrasil Computing Incorporated appears to have pivoted to publishing collections of free and open source software in CD form. That explains the mislabeled tarballs that I found at the start of this project. However, I have found little to any official acknowledgement of the distribution's discontinuation. As far as I can tell, development just stopped. If I had to theorize, it's possible the ongoing maintenance and development were too much for a small corporation, or it was possible that there was simply not enough market for a CD-only based distribution in those critical early years. Lending credence to this theory is that even Microsoft supported floppy-only systems as late as Windows 98. It's on that note that if you've enjoyed this video, consider giving it a like and subscribing. If you really enjoyed this video, consider supporting me on Patreon. As always, this is NCommander, signing out and wishing you all a pleasant day.